you again. This is going to be me to present again because this is a work of a master student of mine, Pedro Carvalho. I'm one of the coordinators of this study, of the supervisors, and this work deals also with the cohesive zone modeling of adhesive bonded joints. But here the objective is to perform a static analysis to adhesively bonded T-joints using the dual adhesive technique to try to improve the strength of the bonded joints. Here we can see the outline of the presentation, beginning with the purpose, a short introduction to the topic, experimental validation, and then a numerical study on the dual adhesive technique before the conclusions. Beginning with the purpose of this work, we want to study the eventual advantage of using the B-adhesive technique in T-joints.
Sorry, we cannot hear you.
Sorry, can you hear me now?
Sorry.
Can you hear me now?
I can hear you, Raul.
Raul?
Okay, yes.
We cannot hear you.
Can you hear me?
I can hear you.
Just a moment, Raul. Here.
Can you hear me now?
From Zoom, I can hear you.
Okay, thank you.
Probably they have a problem in the conference room.
We have some problems with the audio in the just a minute and we solve the problem.
Okay, thank you.
Dal computer non si sente, dalla cosa si sente?
Non sente basso.
Hello?
Hello?
Yes, can you hear me?
Hello? Hello?
Hello?
Hello? Hello? Prova? 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 Raul.
Yes, can you hear me?
La faccio lì.
Questo qui deve parlare dal computer?
Sì, al computer. Intanto lo fa.
Stava parlando dal computer.
Ma dal computer è saltata. No, no, è corretto. Sì, ma c'era questo e siamo passati su quest'altro.
Puoi mandare di nuovo una musica come prima, cambiare?
Sì. Sempre su YouTube. Mi sento la prima che cos'è?
Se chiedere a Raul di cominciare?
Hello, can you hear me?
Perfect.
Okay.
Okay.
Can I start?
Yes, please.
Yes, yes.
Okay, thank you. I will start again, but I will try to be very quick. This work deals with the cohesive zone modeling analysis of T-joints, namely trying to use the dual adhesive technique to improve the strength of the T-bonded joints. This is the layout of the presentation. Purpose, small introduction to the topic, validation with experimental results, numerical study, and conclusions. For the purpose of this work, we want to try to study an eventual advantage of using the B-adhesive technique in T-bonded joints. We are going to begin by validation the CCM technique for static applications, and then to try to obtain the highest strength possible and highest energy absorption in the T-joints. As a short introduction, cohesive zone models are widely used nowadays for strength prediction when we want to combine strength mechanics of materials principles for damage initiation and fracture mechanics principles for damage propagation. And this is the model that we are going to use. For the model's validation, we are considering the same geometry that we used in the optimization study, which is a T-joint, or in this case, a double L joint forming a T. And here, the main parameter that changes in the validation is the value of TP2, which is the thickness of the T adherent. We are going to consider values between 1 and 4 millimeters, and 3 adhesive, just a single adhesive in the bond. And the materials are a medium strength aluminum alloy, the AW6082, and we are going to test the sole behavior of 3 adhesives, the brittle AV138 and 2 ductile adhesives, 2015 and 7752. Here we can see the mechanical properties of the adherents and the 3 adhesives, which were characterized in previous works. We can see, for example, the difference in shear ductility of the 2 adhesives. The Aerolite AV138 is very brittle, while the other ones are ductile. We want to test different behaviors. And for the validation results, we have here the experimental setup and the loading speed of 0.5 millimeters per minute. Here we can see the maximum strength results of the validation study. So these points are the experimental data with the respective standard deviation, and the lines are the numerical points. So for both adhesives, we can see that we have a good correlation between the experimental data and the numerical data. So the maximum error is 4.5%. So we consider the model validated. In the numerical study, we want to address the concept of B-adhesives. So we want to have a ductile adhesive at the edges of the bond, the adhesive in red, and in the middle of the adhesive bond, we want a stiff adhesive. The main objective of this study is to try to improve the maximum load of the joint, because here we have a large asymmetry in the stress distributions. We are going to consider 3 cases of length variation. The red part can be 12.5%, 25 and 33% of the whole overlap. And we have different combinations of the adhesives, always with the more ductile adhesive at the edges, so that we try to uniformize the stress distributions. Here we can see the boundary conditions in the numerical models and the triangular cohesive zone model that we are going to test to assess the strength of the joints. Beginning with the failure modes, we had different failure modes. For example, damage initiation at the inner overlap edges, damage initiation at the outer overlap edges, failure at the transition between the 2 adhesives, the ductile and the brittle, at the inner transition. Here we have the outer transition, and here we have a combined failure at the inner overlap and also at the transition between, at the inner transition between adhesives. And here we summarize the failure modes that we have, in which we can see that depending on the configuration, the failure mode highly depends on the thickness of the T-joint and also on the combination of the adhesives. So there is a large variation of failure modes depending on the condition. Regarding the joint strength, we have in these three graphics the three configurations, and we can see that the best results of the dual adhesive technique was found for the 1/3 each adhesive configuration, in which we always have an improvement of the dual technique compared with the best results of the single adhesive, which is the green one, the 7752. For the other conditions, we only have an improvement of behavior for specific geometrical conditions. Here we have a summary of the results. We can see that in most of the cases, the best configuration was with the dual adhesive technique, and only for 3 cases, this one, and this one, did the best configuration was not a dual adhesive technique. So in terms of strength, we got good results with this technique. On the other hand, regarding the energy absorption, the results were not so good. We actually had an improvement for some configurations, this one and this one, but for most configurations, the single adhesive 7752, which are the green curves, got a better result than the dual adhesive technique. And we can see here the summary of the results. We can see that for most conditions, the best results were found for the single use of the 7752. Only for these 2 conditions, we had an improvement in strength. And here I summarize the conclusions that sum up what I said in the presentation. And once again, I will be available and happy to answer any questions that the audience might have. Thank you.